Okay, so on page 465 it talks about ragged arrays, and basically what a ragged array is, if we take a look, I'm looking at the lengths program, and there we have 3 rows and 4 columns. But do we always have to have that? For example, what if I have 3 rows, and let me get rid of the 8, and let me basically add the 8 down here at the bottom. So what I have now is 4 columns, 3 columns, and now 5 columns. So I've got 3 different lengths in that particular row. Now, how do you deal with that? Well, down here, if we were doing an inner and outer loop, well, we would need to basically do something like this. I would have to basically do for int outer index equals 0, and while the outer, I'm sorry, it's inner index is less than or equal to the numbers dot, I should say, I'm sorry, numbers index dot length. Okay, and I'll say inner index plus plus. Okay, so basically what I'm saying here is, well, I don't need that. So basically what I'm saying here is I'm declaring a new integer index, numeric value. It starts at 0, and while that index is less or equal to numbers, now look at, I'm grabbing the row index. It's the outer index and the inner index dot length. So I want to grab the length, how many columns are in that particular length. Now, as we've seen before, like we've used constants, the 3 and the 4, maybe divisions and quarters, as we saw earlier. We can't rely on that because they're not always going to basically be the same. So with ragged indexes, you're basically going to have different lengths in your columns. So just be aware of that, and then make sure we code smart and code for those types of things. Kind of a word of advice, this is kind of Mark Webb talking. A lot of times we do that. We code for a specific length. So we basically make those code and it works great. And here's what will happen. This happened to me many times as I started my career as a programmer. I would rely on that numeric value always being there. Then all of a sudden, 3-4 years down the road, boom, that program blows up. Next you know, I'm getting a problem ticket, and I don't know why. And the reason being is all of a sudden something new is introduced and that numeric value was no longer valid. So we can't always count on that. So make sure we always code for everything. Don't always assume you're going to have the same length. Okay. So, for example, if we have constants, yeah, we can kind of rely on those. But again, every now and then somebody will update the value of that constant. Will our program work? So again, those are things we always have to be thinking about back here in the back of our mind. Okay, so those are ragged arrays. Now, the next, just very quickly, page 466 talks about 3-dimensional arrays. And that's basically an array. So think of a 2-dimensional array as an array inside of an array. Okay, we've got our outer and our inner. Well, so we've got our table. Okay, so we've got our table for our 2-dimensional array. We've got rows and columns. With a 3-dimensional, think about having each one of those. So think of a mail slot. Okay, at a post office, they've got rows and they've got columns of stuff. Well, think of each one of those slots having now it's got a diagonal board in it. So now I can stick mail in the upper or the lower within each cell. So now I can talk about the row, I can talk about the column, and now each one of those cells has two slots. I have to then use a third array for that. Okay. Very confusing, very hard to kind of grasp in your mind on how those work. That's probably the best way, is think of a mill slot, and then each slot has a divider in there. Okay, so I talk about my row, talk about my column, and then I talk about which slot I'm using inside of that. Now I might have 3 slots inside of each one of those boxes. Okay, so can we go beyond that? We sure can. We can do 4-dimensional, 5-dimensional, 6-dimensional, and I wouldn't even try to fathom going past 3-dimensional arrays. Are they used? Yeah, but boy, they are really hard to kind of grasp to kind of get straight in your mind, so how it works. Usually what people do at that point is they start using databases, your DB2s, your dprop-Rs, your Access, DBase3, whatever happens to be available to them. If you need to go beyond a 3-dimensional, probably a database is where you need to be. So, and that's kind of where most people go when that happens. 467 gets into a thing called a sort and binary search. So once we have stuff in an array, we might need to sort that in a certain order. So let's say, for example, I'm having a user type in names for a student database. They're typing in first name, they're typing in last name. What I might want to do then is then sort that by last name. And we can do that very easily with some of the different sorting algorithms that are available out there. We never try to write one on our own. If you want to try it, by all means try it. But normally what we do is there's a lot of good algorithms, a lot of good code out there that we can actually go out and download. Programmers today rarely ever start code from scratch. We usually find something that's out there and then basically grab that and then build upon it. So on page 467 all the way through, I believe, 470, it basically talks about how the different algorithms work. I actually copied some of the code in here. This is a code actually from the book. So if we take a look here, I've got a selection sort, and I've got 4 different integer variables. I've got a start scan, an index, a min index, a min value. I've initialized the min index and min value to 0. I don't think the book did that, but there were some issues the code was having with that. So I have basically an inner, or I should say an outer and a inner loop. So here I say for start scan equals 0, so I'm creating a brand new, I'm taking the start scan, I'm setting it to 0. And while start scan is less than the array dot length minus 1. Okay, so I want to stay within that. I don't want to basically be equal to that last one. And then I basically increase my start scan by 1 each time I go through the outer loop. So that means when I hit this brace down here, that gets increased by 1. And then I say the min index is equal to start scan. The min value is equal to the array start scan. So whatever we're at right now, at this point, start scan was equal to 0. I'm starting with the very first element of that array. Now, this is a 1-dimensional array, by the way. Okay, this is a 1-dimensional array, so just be aware of that. And then I've got this inner loop where I say for the index equals the start scan plus 1. So I've got a new, it's an integer data type. I've got a new variable index I'm using. I'm setting it to the start scan plus 1. So start scan right now is 0. Index is going to be equal to 1. And the index, while the index is less than the array dot length, let me close it, I got extra space in there. While the array dot length, so let's keep doing this while the array is less than the length, and I'm going to increase the index by 1 each time I go through here. If the array index is less than the min value, which right now is 0, the min value is equal to the array. That might not be right, by the way. Oh no, I'm sorry. Yeah, that's just this. Okay. So here I've set the min value to the very first value in the array. Here I'm grabbing the array. So again, we're using the same exact array, except now I'm looking at, because I've increased it by 1, here's my start scan, plus 1, I'm actually looking at the cell to the right of that. And I'm saying if the value in the cell to the right is less than this cell, then I'm going to say the min value equals the array index. Okay? So my array index, so let's take a look at that. So my very first cell sitting here, the one to the right of it, if it's less than this one, I've got this value called min. I take the value in here and put it in the min. And then I say the min index is equal to the index. Okay? And then I basically keep doing that. Okay? And so min index equals index. So when we get through with this min index is going to hold the index of the smallest item in that array. Okay? Then once we drop out of there, we basically come back up to this guy and we kind of start over again. And let's see what it does. So here it's going to take the array min index equals array start scan. Okay. So when we come through here, yeah, so start scan is going to be the current position. The min index is going to contain the lowest value, and we basically throw that into the array at the current position we're at. And the array start scan equals min value. So in a sense, in the book it does a pretty good job explaining it. Let's see. So basically, here's what it does. I think we need to start on the. Here we go. So here I've got 572891. So the very first thing it does is it goes to this array and it looks for the lowest one, and it finds this one, and it basically does a swap of those two positions. Okay, so that's what that one code was doing that we were just looking at. So we get the lowest value in the very first position. We don't care that the 5 is in that position. We're just doing a swap. Okay, we're just doing a swap. That's all we're worried about right now. So then what we do is we go to the second position and we look for the lowest value. Let me see. Is that the 2? No, yeah. So then after we do this swap, I'm starting at the second position and I go all the way through, and it looks like 2 is the smallest. So I take the 7 and the 2 and I swap them. Okay? So now I have the 1 and the 2. 1's lower than 2. Because I know 1 is the lowest, 2 is the next lowest. Now I start at 7 and I look for the lowest number. This happens to be the 5. And what does it do? It swaps to 7 and the 5. Okay? Then I basically go 1 over and I basically start there and I see that the 7 is now the lowest, so I swap the 7 and the 8. And then I start at the 9 position and I look for the lowest number, I see that the 8 is the lowest.